Okay, so we just finished this one up. The next thing we need to do is the rotation, but rotation's actually it's a little more interesting, a little bit more complex. Because remember, we did the rotation, we were just rotating around one axis, which is actually the z-axis, but I didn't say that to you because I didn't want to confuse you. But now it's time to know that we were pretty much rotating around the z-axis. But now, since this is a Matrix3D, we could technically write a rotation to go around the x-axis. Pretend this is the x-axis coming to the right. We could write a rotation to go around the x-axis. And we could also write a rotation to come around the y-axis as well. And when we go three-dimensional, we actually view three-dimensional. When we get to computer graphics, we will do such. However, all we're trying to solve for our two-dimensional game is rotate around the z-axis just like we were doing before. Alright? Picture that z-axis just poking you right in the face. It's coming out of the screen directly at you, and we want to, or we wish to, rotate around it. Well, the logic's still the same as what we did for the two-dimensional matrices. We're going to have cosine and sine for one basis vector, and then negative sine and cosine for the second basis vector. But we need to be careful where we place those in our matrix. So let's, I'm actually going to cheat, I think, a little bit here and just reuse our tests. Even though I've proven to you that I am terrible at copying and pasting, I'm going to use our Matrix2D tests. I believe we had rotation here. And let's just copy this. Oh, this is scary, but I'm going to copy it. I'm going to go to Matrix3D tests and get rid of this breakpoint. Let's be consistent with our formatting here, though, because we have rotation, we have construction. I can collapse these like this. We have construction, rotation, matrix vector multiply. So let's keep that consistency here with 3D tests as well. Construction, rotation, and matrix multiply. And then Control H, everywhere you see matrix 2D, replace it with matrix 3D. Match case, match whole word, replace all. And then we need the, I don't want to say rotate, because what does that mean to rotate? We're going to rotate around the Z. Alright, so let's, everywhere we say rotate, Control H, I'm going to say rotate. I could say around Z, but it's actually quite common to just say rotate Z. And eventually I'm going to show you how to rotate again against any arbitrary vector, not just the x-axis, the y-axis, the z-axis. But I think for what we're doing here, just because we're learning, we're this educational, let's rotate around the z. So match case, match whole word, replace all, 7 occurrences. And then what's left over? We need to, we're going to have to do a lot of, with the 2x2 we're checking 4 values, but now we have to massage all of these to check against 9 values because we're doing 3x3 matrices. So, but the rest is going to be pretty much the same. So let's see, R0, C0, R0, Z1. This might be painstaking, and maybe we should have. Maybe I should have just typed all this out from the beginning instead of doing the copy paste thing. It's such a debate, such a debate. So row 0, if we rotate around Z0, that should be the identity matrix. So let's see if we can. How are we going to make this easy? Row 1, column 1, 2, and then let's grab this like so. Control C, Control V. But now this is going to be row 2. And then we should just expect the identity matrix to come out of this. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So that should give us the identity matrix. Now we're going to rotate pi, which should give us these negatives as well. But when you think about rotating, now we're doing a 3x3 matrix. So what does that mean to rotate around the z-axis? Let me put our basis vectors down like this. And then we're going, when we rotate around the z, well, before we were doing, weren't we doing something like cosine, sine? This should be old hat by now. Negative sine, cosine, right? We were modifying these values. So to rotate around the z means we're not going to change the z basis vector at all. So this value in our matrix, when we say rotate z, it should always be 0, 0, 1. Okay, I hope that makes sense. It's always 0, 0, 1. This will never change. No matter how many times I call rotate z, we're only going to modify these values here. And these values here, well, we're not going to change them at all. So, I mean, rotating around the z-axis doesn't make the z-axis any longer in any of these basis vectors. So these should always be 0. These should always be 0. This should always be 1. So we can actually just, basically all we need to do is add a bunch of tests to check for zeros and ones, and the rest should be the same. In fact, this is still row 0, column 0. This is still row 1, column 1. This is still row 0, column 1. And this is still row 1, column 1. So we don't need to change any of that as well. All we need to do is add some tests to be sure that all these are zeros and ones. Okay, and that's essentially what we just, well, we just did it here with the identity matrix, but we can do the same there. So I think we're going to use copy and paste to our advantage. So let's look at our pattern that we're doing here. We're doing row 0, row 0. So the next one should be expect float equal op dot row 0 column 2. That should be equal to a 0. And I'm just going to one by one insert this below every row 0 column 1 that we see. So row 0 column 1, well, now there's row 0 column 2. What did I mess up? What did I mess up? Why am I getting close enough as undefined? Control Shift B. Let's ask the compiler. Rotate Z. Well, it's complaining about that, but close enough identifier not defined. Man, what did I just change to mess that up? Oh, it's so hard to talk about this on video and get it right. I don't know. I'll fix it later. Let's put that back in. So row. Oh, I don't dare fix it later. I don't dare fix it later. Let me get this off the screen. Let's just Control Z until something build started. Close enough. Oh, dummy. Let's Control Y all that back in now. We didn't include. Where's close enough? Remember we made this close enough somewhere else. I'm gonna F12 on this. See if Visual Studio will find it for me. It's in the helper functions, duh. All right. Pound include helper functions. Control minus to get back to where we were at. Okay, that's good. Ah, that's a lot better. Okay, what were we doing? We were doing row 0, column 2 is 0. So that should always, forever be the case there. So row 0, column 2 should be 0, row 0. And I think it's easier to do these one by one within the separate tests because all I'm doing here is visually looking for row 0, column 1, and then pasting this line below it. Okay. And you could say, well, Jamie, you don't really need to do that. We know they're always going to be right. Yeah, we could. But I want to be pro. So I'm going to come here. Row 0, column 2. Right here. And that should be all of them. Okay, good. So then what's the next one we need to do? We have row 0, column. We have all of row zeros. Let's go here. We have all of row zeros. But we have row 1, column 0, row 1, column 1. So we need row 1, column 1. Expect float equal op dot row 1, column 1. That should be a 0, right? Should it not? Be row 1, not row 1, column 1. Row 1, column 2. That should be a 0. And then row 2, column 0, that should be a 0. And then row 2, column 1 should be a 0, and row 2, column 2 should be a 1. Okay, so that takes care of the rest of our zeros and our ones. Again, let me just draw that up again for my sanity and for yours. Cosine, sine, negative sine, cosine, 0, 0, 0, 0, 1. So here are these three zeros make up these three zeros there. And then this here. Oh, no, sorry. I got that wrong. These three zeros here make up these three zeros here. And then this 0 here, I strategically placed it here because I wanted it to be right after row 0, column 1. So row 0, column 2, row 1, column 0, row 1, column 1, row 1, column 2 is 0, and then we have row 2, column 0, 1, and 2, 0, 0, 0. Okay. Wow. So this copy-paste job should be a little easier here. I'm just going to grab this, and I basically have to put it at the end of all these blocks of code. Does it help if I sing while I do it? Unit testing can be boring and tedious. And I'm actually quite proud of you if you're following this video as long as you have. And hopefully you're implementing this code. Let's go to, well, we need to make rotateZ for Matrix3D. So let's go Matrix3D.h, and again that's going to be a static factory function. So Matrix3D 3D rotate Z, and I want to say inline on that. Rotate Z, float, what do we call it, in degrees or something? Let me look at Matrix2D H here. Angle in radians, that was right. Inline, oh, it needs to be static too. Static, float, angle in radians. Okay, I'm going to copy this. Let's go over to Solution Explorer and write the implementation. Visual Studio has encountered an exception. This may be caused by an extension. You can get more of running, examining the file, activity log. Okay, whatever. Hopefully you still work and I don't have to restart you, at least not until the next video. Let's put this right here. I don't need to say inline or static anymore. I declared those as inline and static. Went up in the header file. So we just have to do this, do this, do this, do this. Go down here and return a Matrix3D so that all of our tests will fail, or most of them will at least. rotateZ has no member. rotateZ, it does have a member. IntelliSense, I think you're just having a hard day. Pi not defined, because we need to pound include. Do you remember we made a constants file here for that? So pound include math/constants. And I want to be alphabetical as much as possible within the same group of includes. Control-Shift-B. Okay, good. Run. Woo! You didn't see it, but I did. Lots of failure. Oh, that's rough. That's rough. Okay, but it's going to be quite straightforward to get this to pass. So let me, well, yeah, let's make it pass. All right, Matrix3D.inl. Again, forgive me if hopefully this is becoming annoyingly repetitive, but I think it's good to see. We'll do this off. Get some more screen real estate here. And just right here, again, we want to say cosine, sine, negative sine, cosine, and then this will be just 0, 0, 0, 0, 1, like so. So let's do that. And we're going to use the return value optimization trick again, and then return. Do we have math? We don't have math. We need math, which means I have to go to Matrix3D.h and include it up here. Pound include. Oh, Visual Studio. Visual Studio, why do you trouble me so? See math. Okay, cosine, angle in radians. Negative sine angle in radians, 0. Sine angle in radians, cosine angle in radians. I'm actually going to just space that in there to line up with our sine. Looks like CMath. Our CMath isn't working. That's going to be a 0. And then the next row is easy, 0. Let's just format this best we can. 0, 0, 1. Like so. Control-Shift-B. Build started, build succeeded. Okay. Run it. Everything's green. I'm feeling good. Good time to commit. Don't you think so? So I'm going to pause the video and commit. Okay, and then hopefully I hope you were choking on your lunch when you saw me do this again. Do you remember the trick we used over in Matrix3D when we wrote the rotate there? I don't want to call cosine and sine more than I have to, so I'm going to make some temporaries, store them in there, and then use our temporaries. So float. Oh, heck, why not? Copy. Paste. Oh, I feel like such a hypocrite. That's probably because I am. Cosine result. Cosine result. Sine result. Sine result. And that just messed up a lot of my formatting. But I'm going to be picky. I want a nice clean house. And format this again. Like so. Control F5. Get all green. Good time to commit. But that's nice. I have the unit test now. And I can do refactorings like this and feel good about it. So there you go. Rotation around the z-axis using a 3-dimensional vector.